Hello class, welcome to section 5.4 day 2. We are going to continue looking at integration of inverse trigonometric functions. So all of our inverse trig functions we have listed here along with their derivatives. Okay, and then the nice thing is we know that if we just take the antiderivative of each one of these, you will go back to where we started. So if I take the antiderivative of this with respect to du, this is sine inverse. Okay. So making sure you have these derivatives and these antiderivatives down is important. One thing I would notice about all of these is, you guys see on the bottom they all have a 1, okay, and they all have something squared. Okay, so yesterday we had problems. Let's say we had 1 plus x to the 6th on the bottom, and so what we had to do was we had to rewrite just this piece. Okay, so we would write as 1 plus x to the 3rd squared to have that squared part. Okay, however, okay, then I can have something that looks like this. However, today, this will not always be a 1. Okay, so there's an extra added step. So here is example 1. This is not a 1. So what we do is we're going to factor out a 25 in our denominator. Okay, so we're going to have the integral of e to the 3x on the top. And I'm going to factor out a 25, so 25 parenthesis. Now when I factor this out, I'm really dividing each one of these by 25. So I have 1 plus e to the 6th x divided by 25 dx. Now from here I see I have my 1, which is good, but this part needs to be rewritten as something squared. So I am going to rewrite it as something squared. We will have 25, and then you have 1 plus e to the, it'll be 3x, and then 5 squared dx. And I got my numerator stays the same. Okay, so one thing I would notice is if I were to re-square this, it should go back to what I have here. So 3 times 2 will give me 6x, and then 5 squared is 25. So there, that is good. And now we're back to the type of problem we were doing yesterday. Okay, what is inside here? We pick to be our u. So u equals e to the 3x over 5. And we take the derivative of it. So you could also think about this as 1/5 e to the 3x. So 1/5 is a constant, so the derivative, the 1/5 will stay in front. And then the derivative of e to the 3x is really a chain rule. Okay, so the derivative of the outside is really e to the x, so the derivative of that will stay e with the original inside times the derivative of the inside, so times the derivative of 3x, which is 3 dx. Okay, so what I have is du is really equal to, I'm going to say 1 times 3 is 3 over 5 e to the 3x dx. And I'm going to sub this in here, and I'm actually going to solve for what dx is. Okay, so in order to get dx by itself, I would multiply by the reciprocal of this. Okay, and I would have to divide, this is really over 1, divide by e to the 3x. So I will have 5 over 3e to the 3x du equals dx. Okay, and I'm going to sub all of this in for my dx. So rewriting this, I have, my numerator is the same. I'm going to run out of room. 25, and then I have 1 plus u squared times my dx, which is all of this, 5 over 3 e to the 3x, sorry, it's getting crowded, du. Now from here, this is a 3, this is an e to the 3x, and this is an e to the 3x. I will see that those will cancel. Then my 5 and my 25 will actually reduce. This will be 1, this will be 5. So I really have 1 times 3, which is 15, and notice it's in the denominator. So in the front, I'm going to pull out a 1/15. Then I will have in my numerator 1 over 1 plus u squared du. Now that I've done all of that, I can go ahead and take my antiderivative. I would say, who does this look like? The ones that don't have square roots are tangent and cotangent, and since it's positive, it is going to be tangent inverse. So we have 1 over 15 tangent inverse of u plus c, and then you have to remember to go ahead and plug in what u is at the very end. Okay, so u is this guy. So we would have e to the 3x all over 5 plus c. Oop, that got crazy. There we go. Maybe a little better. Good. So there's our answer for example 1. Okay. Example 2 is the same idea. Okay, I look at it and I see there's a square root and I see something squared, but I don't have just a 1 here. So what I'm going to do is I'm going to factor out that number so that I can have a 1. So I will have the integral of the square root of 36 and then parentheses. If I divide this by 36 and I divide this by 36, I will have 1 minus x squared over 36 dx. And I'm going to do 2 things in my next step. I'm going to say, well, what is the square root of 36? And put it out here. So that's going to be 6. So I will have 8. I'll have a 6 in front. The other thing I'm going to do in my next step is I'm going to rewrite this as something squared. So it's really 1 minus, and then in parentheses, I would have x over 6 squared dx. Okay. And I check x squared is x and 6 squared is 36. So then it goes back to what I had. Now I'm going to pick u. Okay, and notice, you guys, I'm not pulling out my constants until after I do my u sub because things might cancel. I mean, if you pull it out, you'll eventually cancel it. So just be careful if you do that. So I'm going to pick u to be x over 6. So u equals x over 6. And then I take the derivative of it. Remember, this is really 1/6 x. So if I take the derivative of it, u equals 1/6 dx. Sorry, du equals 1/6 dx. If I get dx by itself, I'm going to times both sides by 6. So I have 6 du equals dx. And now I'm just going to go ahead and sub everybody in. Putting u in here. And I know what dx is, so I'm going to write that here. So I have 6 square root of 1 minus u squared. I have 8 here, times 6 du. So this is really over 1. I will see that my 6's will cancel. And so my constant is 8. Put that in the front. I have 1 over the square root of 1 minus u squared du. And then I just have to think about which function it is. Okay, it's positive, so I know it's not an inverse trig function that starts with a c, and it's a square root, so it is actually going to be sine. Okay, if you go back and look, you'd see it, but this is 8 sine inverse of u plus c. And then don't forget, plug in what u is. That will be your final step to get your answer. Okay, so 8 sine inverse of x over 6 plus c. Okay. So the new step today is that if this is not a 1, you have to factor out that number. Okay, and then you can continue with u sub like we did yesterday. So that is it for the notes. If you have questions, please feel free to message me. But you have your integration of inverse trig worksheet from the day before. You should go ahead and finish that in its entirety. Okay, I will see you later. Have a good day. Talk to you then.